So to solve a rational function, we have the following example. f of x equals x to the power of 2 plus 3x over x to the power of 2 plus x minus 6. So in order to solve this, we will first find the vertical asymptote, since that's going to be the easiest. But we're going to have to factor this equation. So for the numerator, we're going to take the x out since they have an x in common, and it will become x plus 3. And then into the denominator, we're going to have to factor everything here. So it's going to become x plus 3, x minus 2. So now, to find the vertical asymptote, we're going to have to set the denominator to 0. That means kind of like solve for every x. So here, we're going to do first x plus 3 equals 0, which will give us x equals negative 3. We have our first vertical asymptote. For the next one, we're going to have to do x minus 2 equals 0, and that would give us x equals positive 2. That's our second vertical asymptote. So now that we have the vertical asymptotes, we're gonna do the domain. We're gonna start with negative infinity to negative 3 union negative 3 positive 2 union 2 to positive infinity. Now that we have all of this, we can start graphing. And for the vertical asymptote, since it's at negative 3, we can start negative 3. That's our vertical asymptote. And the other one's going to be at 2. Okay. So now we're going to follow up with the horizontal asymptote, and for that we're going to use the acronym Bobo Bottom Eats DC, but the one that applies to right now is going to be Eats DC, since we're having over here we have the same exponent on the numerator and the denominator, so that makes it that we're gonna have to divide the coefficient. The coefficient here, it's gonna be 1. Since we don't have anything, it's still 1, so it's 1 divided by 1, that's gonna be 1. So the horizontal asymptote is y equals 1. So now to find the x-intercept, we're gonna have to set the numerator to 0. So we're gonna grab all of this x squared plus 3x equals 0. But we're gonna set the x to 0. 0 squared plus 3 times 0, which all of that same, it's gonna equal to 0. So our ordered pair is gonna come to be to 0, 0. After that comes the y-intercept. Now that we have the x-intercept, we're going to solve for the y-intercept. We're going to have to plug in the 0 for every single one for every single x. So it's going to be 0 squared plus 3 times 0 over 0 squared plus 0 minus 6, which will give us 0 over negative 6. But let's remember that everything divided by 0 is going to give us 0. So our ordered pair is going to be the same, 0, 0. So now, the only thing that we have left is the wholes. So if we go back to the factor form, we notice that there's a common factor in the numerator and the denominator, and that is the x plus 3. So we're going to cross them out. X plus 3, x plus 3. Since there's not going to be a point there. So what we are left with is x over x minus 2. Now we have to plug in, since we have the vertical asymptote to be -3, that is going to be what we plug in for x. So it's going to be -3 over -3 minus 2, which is going to come up to be -3 over -5. And since we're dividing a negative by a negative, it's going to become a positive, so it's 3/5. So our whole is going to be found at -3, 3 and 3/5. So that's going to be where there's not going to be a point crossing. So now, to complete the graph, we're going to plug in that horizontal asymptote, that is y equals 1, and that will be going to be here. Y equals 1. This is 1. So now that we have our vertical asymptote and our horizontal asymptote, we're going to plug in the x-intercept, that it's going to be at 0. And we're going to use another color. It's going to be at 0. And our y-intercept happens to be at the same spot, so we're just going to leave it like that, at 0. So now that we have our x-intercept and our y-intercept, we're going to plug in the hole. And let's remember this, that since there is a hole, there's going to be no vertical asymptote at that point. So we're going to cross this out, so we're going to get rid of the -3 vertical asymptote. And instead, now we're going to plug in the hole. That's going to be at -3, 3/5. So it's still going to be at -3. It's going to be 3/5. So it's going to be like right here. Somewhere right there. So now we're going to connect the dots, and it's going to be coming down here. Connect with the other. And since the multiplicity is of 1 for this particular function, the other graph is going to be diagonally from this graph. So it's going to be going like this here. There. And that is how you graph a rational function.